Hi, it's me, your statistics teacher. Today in this class we will learn equally likely events, mutually exclusive events, favorable cases, result of experiment, sample point and sample space, and finally probability. Okay, let's start. Equally likely events or cases. Events or cases are said to be equally likely when none of them is expected to occur more frequently than the other. For example, A. In tossing an unbiased or uniform coin, the case of appearing head, H, or tail, T, is equally likely. B. In throwing an unbiased die, all the 6 faces are equally likely to come. Mutually exclusive events or cases. Events or cases are said to be mutually exclusive if the occurrence of one of them excludes the occurrence of all others, that is, if no 2 or more of them can happen simultaneously in the same trial. For example, in throwing a die, all the 6 faces numbered from 1 to 6 are mutually exclusive since any one of these faces comes. The possibility of others in the same trail is ruled out. Similarly, in tossing a coin, the events head and tail are mutually exclusive. Favorable cases. The number of outcomes which entail the happening of the event in a trail is called the favorable cases. For example, A. In drawing a card from a pack of cards, the number of cases favorable to drawing of an ace is 4, for drawing a spade card is 13, and for drawing a red card is 26. B. In throwing of 2 dice, the number of cases favorable to getting the sum 5 is 1, 4. For 1, 2, 3, 3, 2, that is 4. Result of experiment. The outcome of an experiment is called result of experiment. Sample point and sample space. Each conceivable outcome of a conceptual experiment that can be repeated under essentially similar conditions is called a sample point, and the totality of these sample points is called the sample space. For example, if an experiment consists from the random tosses of 2 coins, then 4 outcomes can occur, and they are H, 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 T, T, H, T, T. Each of them is called sample point, and if we denote them by S, then S is called sample space. S is equal to HH, HT, TH, TT. Now we will learn the definition of probability. There are mainly 2 definitions of probability, namely, 1. Mathematical or classical or a priori definition of probability. 2. Statistical or empirical or a posteriori definition of probability. Mathematical or classical or a priori definition of probability. If a trail results in n exhaustive mutually exclusive and equally likely cases, and m of them are favorable to an event A, then the probability p of the happening of A is given by p is equal to favorable number of cases divided by total number of cases, that is m by n. This gives the numerical measure of probability. Obviously, p is a positive number and not greater than unity. So that p lies between 0 and 1, since the number of cases in which the event A will not happen is n minus m. The probability q that the event will not happen is given by q is equal to n minus m divided by n, which is equal to 1 minus m divided by n, that is 1 minus p, so that p plus q is equal to 1. Statistical or empirical or a posteriori definition of probability. If a trail is repeated a number of times essentially under the same condition, then the limit of the ratio of the number of times that an event happens to the total number of trials, as the number of trials increase indefinitely, is called the probability of the happening of that event. It is assumed that limit is finite and unique. Symbolically, if n be the number of cases of a trail A and m be the number cases that the trail A can happen, then the probability p of the happening of the trail A is given by p is equal to limit n tends to infinitive m divided by n. That's all for today. And in the next class we will learn other things related to probability. Thanks to you all. Have a good day.